We're back at the DCC review packet for the final, the first one, and we're picking up at number 5, which is now we're going to take a look at this. We're focusing on trig. And before we jump into this, I want you guys to take out your formulas to know for the final worksheet. And something we should know for our final is the unit circle, because trig is based on that. So remember, if you have your unit circle, right, you make your x and y axis, you draw a circle, right? And the fact that it's a unit circle means this is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right, we also know in the unit circle there are degrees. This is 0, 90, 180, 270, and back around again is 360. But we also need to know those in radians. Now, in radians, right, this would be 0. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. And 360 is 2 pi. So that's our unit circle. And a lot of the trig comes right off of this. So let's take a look at the first one. Cosine is 13 pi over 2. That means pi over 2 was 90s. So I want to know what the 13th 90 was. Well, let's check this out. This is 0. This is 190, 2 90s, 3 90s, 4 90s, 5, 6, 7, 8, 9, 10, 11, 12. This is the 13th 90. That's what 13, 3 pi over 2 means. The 13th 90. So we land here. Now the trick is, there's a point. Which of these is sine and cosine? Well, I'm hoping you remember that sine of theta is y. Cos of theta is x, and tangent is sine over cosine, which is y over x. All right, so this question is asking, what is cosine at that spot? Well, what's the x value at that spot? And that would be 0. So this guy is 0. All right. Now, secant. Whoa, what the heck is secant? Well, remember, there's more than just these guys. There's sine, cosine, and tangent. And then there are the reciprocal trig functions. Right? There's secant, cosecant, and cotangent. Secant is 1 over cosine, and if you remember, it's always the opposite letters, which would make this one 1 over sine, and cotangent is 1 over tangent, or you could write cosine over sine. Another issue, what the heck is pi over 3? Well, we know these guys, right? But there's also pi over 3, pi over 4, and pi over 6. Do you guys remember what those are in degrees? Rule is, quick way, see these numbers? It's always the opposite. This is 180 divided by 3, which is 60. So that's what I mean by opposite. This would be 180 divided by 6, which is 30. And 180 divided by 4, so that's 45 degrees. So what this question is asking is, what is secant of 30 degrees? Or I take that back, secant is 60 degrees. And to know that, you have to know your special right angles. Right? Remember how the side across from 30 degrees is always a half? Side across from 60 is radical 3 over 2, right? And the side across from 45 is radical 2 over 2. So now, secant of 60 degrees, that's what pi over 3 is, right? Means I got to draw a 60-degree angle. Draw a triangle. That angle is 60. It means this angle is 30. The side across from 30 is a half. The side across from 60 is radical 3 over 2. Now, who is secant related to? Secant is related to cosine, right? 1 over cos. So cosine is always what's on the x-axis. So here is cosine. So that means cosine would be equal to a half. But secant is the reciprocal. So secant, we go all the way back now over here, is number 2. All right, so that's the answer to that guy. Tangent, radical 3 over t. Now this is arctan. Right? So arctan is a whole other can of worms. Then there's the inverse trig functions. Right? The inverse trig functions, right? There's arc sine, right? There's arc cos, and there's arc tan. And we usually say that they're equal to y. Now the arcs are equivalent to the negative ones. Right? Now there's special ranges for these guys. Arc sine, the only answers we can have are from negative pi over 2 to positive pi over 2. Arc cos was from 0 to pi. And arc tan is the same as arc sine, except there's no lines underneath it. All right, so these guys have special answers. Now, what this question is asking is what angle, so anytime it's arc starts with an A, you give me an angle answer. So this question is asking what angle tangent equal to radical 3 over 3. And do you guys remember what that is? With all the 3's, it is 30 degrees. And let's talk about why that is. If I were to graph 30 degrees, right? What's the side across from 30 have to be? So what's the side across from 60 have to be? Right? Tangent is y over x. So if I do keep, change, flip, I get 1 over radical 3. And then if I fix this by rationalizing it, I get radical 3 over 3. So that's why radical 3 over 3, and the way I used to know this at your age was tangent with lots of 3's is 30, which is the same thing as pi over 6. We always want our answers in radians. And again, on the final, you'll have this sheet, so you guys should be making this. This is what's going to help you get through your final. So the answer, right, for 30 degrees is pi over 6. So that answer is pi over 6 right there. All right. Now this one is a two-step question. Right? Wants us to do cos 7 pi over 6, then the arc cos. So let's start off with, now some of you are probably thinking, can't these just cancel? Sometimes. And when is the sometimes? If the regular trig was on the outside, these would just cancel and that would be the answer. But if the arc is on the outside, you actually have to do all the work out. So let's talk about this question. This question is cos to the negative 1, cos, I believe it was 7 pi over 6, right? Double check. Yes. So we've got to do cos 7 pi over 6 first. So pi over 6, how many degrees was that? It's 30 degrees. So that means this question turns out to be cos 210 to start. 7 times 30 is 210. So let's sketch 210. 0, 90, 180. So 210 pulls me here. And I make a right triangle. Now if this is 180 and this is 210, that means this angle right there has to be 30 degrees. Across from 30 is a half. Across from 60, which would be this corner, is radical 3 over 2. Now, cosine. Is cosine x or is cosine y? Cosine is x. All right, now, something we have not talked about yet. The quadrants we are in matter. You guys remember the lettering? That goes back to our formulas we need to know for the final, right? We're going to add this onto that. I'm going to add on there A, S, T, C. All right. Now notice, look what quadrant we're in. We're in the third quadrant. The third quadrant has a T in it. The T means tangent is positive, but only tangent is positive. So what does that mean cosine is going to be? 2. Okay. So we're done with the first part of the question. Now we have to do the arc part. Now, arc cos, we talked about a minute ago. Arc cos has a special restrictions. If we go back to our formula sheet, arc cos can only live between 0 and 180. Okay, so right now I'm going to draw my x and y axis. Arc cos can only be from 0 to 180, so these two quadrants are out. The fact that this is negative means the first quadrant is out because A is the first quadrant. What does A stand for? A is all is positive. So that means we're going to have a triangle in the second quadrant. Now, notice my reference angle here is 30, right? That means this is still going to be 30. The reference angle still holds. So how far is it from here to here now? Well, 180 minus 30 means that this is a 150 degree angle. That's the answer to this question. Arc cos means you have to give me an angle answer. So that's going to be 150. But we always want the answer in radians. So let's go back to these three. Which of these three can you multiply by a number to make 150? And a hint, it's always the reference angle. See 30? 30 times 5 makes 150. So 5 times this guy would be the answer. The answer for B is going to be 5 pi over 6. And finally, let's take a look at this guy. So the last question on part number 5, which turned out to be a doozy, is log radical 7 over power is 1. So now we got to find this answer. What the heck is this equal to? Well, we're going to bend this. What's the base? Radical 7. The exponent is question mark. Don't know what it is, but it's got to equal 1. What exponent can you raise something to and have it be equal to 1? And that is 0, which I believe I did have on the last worksheet. But we had a lot to review in order to get there. A lot of you did have that, by the way. Now, one last thing I do want to go over, and what you have to have on your formulas to know for the final. So, continuing on, formulas to know for the final, right, are, see the first one there, sine 2x, are our double angle formulas, right? So we're going to do the double angle formulas. Okay. Sine of 2x is equal to 2 sine x cos x. And then there were 3 of them for cosine. Right? The first one's going to be cos squared x minus sine squared x. Right? Then there's 2 cos squared x minus 1. And 1 minus 2 sine squared x. Those of you taking calculus next year, these are going to show up quite a bit. Right? These are going to show up quite a bit. So what I want you guys to do now, make sure you have these memorized. Also, what we want to have are the sum and difference formulas. Now, you can kind of get through calculus without these, but you definitely need these for calculus. All right, the sum and difference formulas. There's sine A plus B, sine B. There's cos A plus B, which is cos A, cos B minus sine A, sine B. Then there's sine A minus B, right, which is sine A, cos B minus cos A, sine B. And cos A minus B, which is cos A, cos B, plus sine A, sine B. So I'm going to stop there now for the video. The big thing you guys need to take from today in this video is there's a whole lot of formulas you're going to need for your final. So if you guys can create this sheet with all of these on there, right? So all of these and then all of these, you can have them all located in one place for the day we have to take that exam. So that's worth doing. All right, what I'm going to have you guys to try to do next is number 6 and number 7. And then we'll move on to the rest of the stuff.